All right, students, this is lesson 5.3, slope-intercept form. You will learn to write linear equations using slope-intercept form and graph linear equations with slope-intercept form. Just to let you know what that is, I'll just put it up here real quick. Like that, where you have something times x, and if we cover up if we didn't have this part, or if we were adding 0, then it would be a direct variation. But any linear equation can be written in this form. So for number 1, which equation is not a linear equation? We want to pick the one that's not written like that, some number times x plus something. And that would be this one here. Place a check in the box if the statement applies to the graph of a linear equation. Graph of a linear equation is always a horizontal line. That's not always a horizontal line. The graph of a linear equation is always a straight line. That is true. The graph of a linear equation may be shaped like a U. That is false. Okay? So using your vocabulary during a football game, the home team's quarterback threw an interception. The y-coordinate of the point where graph crosses the y-axis is a y-intercept. The teacher intercepted the message Charlie was passing to his friend. All right. So here's the key concept. A slope-intercept form of the linear equation of a non-vertical line is y equals mx plus b. The slope of the line is m. The y-intercept is b. Use the word slope, y-intercept, slope-intercept form to complete the diagram. Right. The 4 would be the slope of the line. So 6 would be the y-intercept of the line. And the whole equation is called the slope-intercept form. All right. So if we look at this equation, what are the slope, what is the y-intercept? Well, from what we just learned, the slope is the number we multiply by x, which the name for that is the coefficient. So the coefficient in the equation is the slope of the graph. So slope equals 3, and y-intercept is the starting point. It's the place where the input is 0. So if we put 0 in there, 3 times 0 is 0, minus 6, that is the y-intercept, which is negative 6. And it's actually the number we're adding. So if I change this to adding a negative and look at that number, that's the y-intercept. So the y-intercept is negative 6. So the places it crosses the y-axis is negative 6. All right, let's look at another one here. So we found out that the coefficient is the slope. So the slope in this case is 5. And we also found out that the y-intercept is the number added in the equation when it's written in slope-intercept form. So we need to change this to addition to figure out what that is. Since we're adding 2, the y-intercept is negative 2. All right? Problem 2, writing an equation in slope-intercept form. Same thing. This is our form right here. We need to figure out what the slope is, what the y-intercept is to write the equation. We're given the slope is 5, so we're going to substitute 5 for m. And we're given the y-intercept is 8, and that is the thing that we add on, so we're going to add on 8, and then that's the equation in slope-intercept form. All right, so try this problem. Write the numbers 3/2 and -1 in the correct boxes below. The slope is 3/2. That's the coefficient, the number we multiply by x. And the y-intercept is -1. That's what we add on to the end. But we're going to simplify that just a little bit and write that as y equals 3/2 x minus 1. Adding a negative is the same as subtracting. Which equation represents the line shown? To figure that out, we want to know the slope of the line, and we want to know the y-intercept of the line. Right here is the y-axis. So we can see right here that the y-intercept is -2. That's the place it crosses the y-axis. So we need an equation with -2. That eliminates two equations. Now we just need to know the slope. And to find the slope, we're just going to pick a couple of points here. Find the rise and the run. Rise is 3, run is 1, so the slope is 3 divided by 1, which is 3. So that eliminates C, and our answer is A because that has a slope of 3 and a y-intercept of 2. All right? Go ahead and try this problem, pause it, and you can check back for the answers. All right, we'll continue on the lesson. Here's your answers. You did it correctly. I may have chose different points, but those are the ones I chose. All right, what is an equation of slope-intercept form of the line that passes through the points? 1, -6, and -3, 10. To find this equation, we need two things. We need a slope, and we need a y-intercept. All right, so for our rule, to find the slope when you're given 2 points, we're going to use this formula. And so we're going to take 10 minus -6 for our rise, and we are going to take -3 minus 1 for our run, and that equals 16 over -4, which is -4. Our slope is -4, so we now have the m part. We can substitute that for m. Now we just need to know the y-intercept. Okay? Now remember, this is a rule that works for these 2 points. These 2 points will be solutions since it passes through them. So what we're looking for is, think about this. We know that when x is 1, y is -6, and we know that when x is -3, y is 10. So, and we also know that we are going to be multiplying x by -4 in the equation, because the slope is -4. So if I take -4, and I'll do my work over here, if I take -4 times x, my x value, that means here I'm taking -4 times 1. Well, that's equal to -4. And if I take -4 times -3, that's equal to 12. Well, the y-intercept is the value we're going to add to our rule that makes the y value is equal to that. So here I am at 12, but I need to get to 10, so I'm thinking, what should I add? So basically, what number times added to 12 equals 10? And what number added to -4 gives us -6? And in both cases, you probably figured out that that's -2. So my equation is y equals -4x plus -2, or -4x minus 2. And just to check to make sure that's right, remember that both of these points are solutions. So in other words, if I substitute 1 for x, so -4 times 1, and subtract 2, that better equal my y value, which is -6. So just check to make sure that's true. -4 times 1 is -4 minus 2, and -4 minus 2 equals -6. So that checks. And then for the other point, it also has to work if I got the right rule. So when I input -3 into this formula, which is this x value, and subtract 2, it has to equal 10. So 10 is that equal to -4 times -3 is positive 12 minus 2, and that's right. So got the right answer. Now I'm going to go back and just do show you one more way to do this because I think this might be a little bit confusing. But let's say we know that much of the equation, y equals negative 4x, and we know we need to add some b value, some y-intercept. All right? And I know that these two solutions have to work. So if I substitute one of those x values in here, and I'm going to take negative 3 substitute, and then I add my y-intercept, that has to equal the y value, which is 10. So 10 has to equal 12 plus 2. So if I subtract 12 from both sides, I get negative 2 is equal to 2. And so I can finish my equation and put negative 2 for my b. And just to simplify that a little, I can write it as y equals negative 4x minus 3. All right, go ahead and try that. Pause here. Now, one thing on this problem, you may have substituted the other point for these two values, so you could also have negative 2 right here and 3 right here, but it should come up with the same y-intercept. All right, graphing a linear equation. This isn't too hard. We have some really nice clues here. We know that the slope is 1/2. We know that the y-intercept is, if we write it in slope-intercept form, by changing that to adding a negative 1, we know the y-intercept is negative 1. So we have 1 point on the graph right there, negative 1. And we know the slope is 1/2. And slope, remember, is rise over run. So we can think of the rise as 1 and the run 2. So that means if I go up 1 over 2, so both of those arrows are in a positive direction, there'll be another point on this line. If I do that again, up 1, right 2, there'll be another point, and so on. And then I can just draw a line that continues through those points. And that's the graph. All right, go ahead, you try it. Check back with the answer. All right, so modeling a function. Carpenter charges $45 fee plus $30 per hour for the writing equation to model the total cost. What graph models the total cost? So, thinking about this, the part that keeps getting added is $30 per hour. And so that means that our fee is going to go up 30. So if we're writing an equation, and we're using, and we know it goes up by the same amount, that means we can use this form to write the equation. So we can write for y, and that would be the amount we charge, is equal to 30 times x plus 45. Now, if we were to draw a graph of that, we know that, and I'm just going to sketch a quick graph, we know that we would start at the y-intercept, so 45, so this would be 45 on the y-axis, and this would be the hours that we work, and every hour this would go up by $30. So we know that this graph would be a linear graph. And it could be continuous if they get charged for part of an hour. All right, go ahead and try that one on your own. All right, so here's your answers to that. You are now going to be part of this group. Here's your answers to the lesson check. We'll see you tomorrow.
Okay.
Say hi, David.
Hi.